What we're doing now is the 2012 SE's official exam scripts, paper 2, project maths, leaving cert ordinary level. Okay, so 2012, paper 2, ordinary level. Okay, so we're going to go straight into this. Peter and Eve go to a large school. One morning they arrive early. When they are waiting, they decide to guess whether each of the next 3 students to come in the door will be a boy or a girl. Write out a sample space showing all the possible outcomes. For example, B girl girl is one outcome, represent boy girl girl. Okay, so what we can have here is boy, 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 3 boys, 2 boys, 1 girl. Now the system I use is I basically move the girl over. So then I have boy, girl, boy. Move the girl over one other time, and then we have girl, boy, boy. Now down the opposite end, we'll also have girl, girl, girl. Now I'll have 2 girls, 1 boy. Girl, girl, boy. Move the boy across. Girl, boy, girl. Move the boy across one at a time. We have boy, girl, girl. I seem to have 8 outcomes. So a total of 8 outcomes of different combinations that can happen. Pierre says these outcomes are equally likely. Neve says they are not. What do you need to know about the students in the school to decide each is correct? You need to know the number of boys and girls in the school. In the school. Basically, if the choice of getting they're equally likely if it's 50-50, as in there's 50% girls, 50% boys. But because most schools there isn't, it'll be biased to either girls or boys. Okay. Now, if all outcomes are equally likely, what's the probability that the 3 students will be 2 girls followed by a boy? So it has to be girl, girl, boy. So you want the probability of getting girl, girl, boy, and that is going to be 1/8. So if you go back to your top, there's only 1 girl, girl, boy. This one here, and it's a 1 in 8 chance. 1 in 8 can be represented in decimals as 1.25, or can be represented if you multiply it by 100 over 1 as a percentage of 12.5%. Okay. Neve guesses that there will be at least 1 girl among the next 3 students. Pierre guesses that the next 3 students will either be 3 boys or 2 boys and a girl. Which is more likely to be correct, assuming all outcomes are equally likely? Okay, so for every outcome, there's going to be a 1 in 8 chance, because there's 1 out of 8 outcomes. Now, what Peter's guess, okay? So Peter wants 3 boys, so Peter either wants he wants boy, 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 or 2 boys and a girl. So 2 boys and a girl would be boy, boy, girl, boy, girl, boy, and girl, boy, boy. Peter's guesses is 4 out of 8. He takes 4 outcomes out of 8, which is a half, okay, or 50%. Now, and Neve guesses there'll be 1 girl amongst the next 3 students. At least 1 girl. So Neve can have 3 girls. She can have 2 girls, 1 boy. So 2 girls, 1 boy would be girl, boy, girl. The next one would be boy, girl, girl. Okay. And there will be at least 1 girl, and she's also allowed to have basically she's allowed to have boy, boy, girl as well, because she only needs 1 girl to make this work. So boy, girl, boy, and then girl, boy, boy. And what we can see is Neve basically has used 7 out of 8. Okay, and basically 87.5%. So we can see that which is more likely to be correct? Neve is more likely to be correct, and we're just after justifying our answer by giving the stats there. So Neve is more likely to be correct because of the greater probability. be correct because of the greater probability. Okay. Next question we're on is question 2. In the Venn diagram below, the universal set is 52 playing cards. The two sets shown represents clubs and picture cards. Okay, for those of you not familiar with playing cards, there's 52 cards in a deck. They're broken up into 13 diamonds, 13 hearts. Now the 13 diamonds and the 13 hearts, these are red cards, okay? So these cards are in red. And then finally after that, there's going to be black cards, and they are called clubs and spades. So it's going to be 13 clubs and 13 spades, and these are black cards, okay? In each 13, the 13 is going from numbers 1 to 10. Okay, so numbers 1 to 10, or sorry, more so 2 to 10 and ace. Okay, ace can count as number 1 or higher, right? So there's 2 to 10. So this incorporates 10 cards that have no pictures on them. However, there's 3 picture cards, and the picture cards Jack, Queen and King are the 11th, 12th and 13th card respectively, okay? Depending on whether ace is high or low. These are 3 picture cards. So in each set of 13 there's 3 picture cards, okay? So 3, and that would make a total of 12 out of 52 are picture cards, okay? So let's begin off by having a quick look here, right? Now what it wants us to do is it'd like us to, in the Venn diagram below, the universal set is 52 playing cards. The 2 sets shown represent clubs and picture cards. Show the diagram of the number of elements in each set. So what we have in the middle is basically, always start in the middle, we have clubs and picture cards. So in the 13 clubs, there's 3 picture cards, which we'll put 3 here. Now that 3 of them are in use, there's 9 clubs remaining. Oh, sorry, 10 clubs remaining. So it adds up to the 13, alright? So that's 10 and 3 is 13. There's 9 picture cards at the start, or sorry, not 9 picture cards. There's 12 picture cards. So each set has 3 picture cards. So 3 diamonds, 3 hearts, 3 clubs, 3 spades. 3 of them have gone missing, and that leaves 9 left over. And then take away all these from 52. So you have 52 minus 10 minus 3 minus 9, and that will leave you 30 cards on the outside. Okay, now that that's done, a card is drawn from a pack of 52 cards. Find the probability that the card drawn is a king of clubs. There's only 1 king of clubs in the full deck. That makes it a 1 in 52 chance. Okay. A card drawn is drawn from a pack of 52 cards. Find the probability that the card drawn is a club or a picture card. The word or means plus. Add the probabilities together. Okay. Now, it's a club or a picture card. Okay. So what we have here is, this is clubs. This is a club and picture card and a picture card. So if we add all these up together, we're going to get 22. Okay, so it's going to be 22. Sorry, there's a chance of 10 clubs, and then there's a chance of 3 clubs and 3 clubs that are also picture cards at the same time, and then there's a chance of just a picture card only, and this gets you 12. So the answer is 12 out of 52. Now another way of going through this answer would be to do something like this, okay? You can say that there's 13 out of 52 clubs. Then you can say there's 12 out of 52 picture cards. So this is clubs, this is picture cards. And then what you gotta do is you gotta take away what you double counted. You double counted the picture cards that are clubs, the club picture cards, which is 3 out of 52. I said it's 22. Sorry, 22 out of 52, guys. Sorry, excuse me about that. 22 out of 52 is 11 out of 26 for that question there. Excuse me. So this clubs, picture cards, and the 3 out of 52 clubs that are picture cards. And what happens is, if you were to do it this way, it also the answer also turns out to be 22 out of 52, which is 11 out of 26. Okay. 2 cards are drawn from a pack of 52 cards. Find that the probability of neither of them is a club or picture card. Give your answer correct to 2 decimal places. First thing to remember is it doesn't say it's not replaced. So cards aren't not replaced. Okay. Second thing is go through the language. Give your answer correct to 2 decimal places. Find the probability that neither of them is a club or a picture card. So this is an AND question, which means multiply. You want the probability that neither one is a club or a picture card. The first probability is going to be out of 52. The second probability is going to be out of 51. We go back to the top. There's 30 of them that are neither a club or a picture card. So there's 30 out of 52. We successfully pull one, which is not a club or a picture card. Then we have 29 remaining. So it's going to be 30 multiplied by 20. It's going to be 30 over 52 multiplied by 29 over 51. And what we get here is 104. Wants it to correct 2 decimal places. So what answer I'd get here is 0.328. And that will correspond up to 0.33. Okay. Next one. Plot the 4 points on the diagram below. Please remember that x-axis means how much left or right the point is. So if it's to the left of the y-axis, it's a minus, and if it's to the right, it's plus. The y, so it goes x and y, and the y means how up or down it is. It's down if it's minus, below the x-axis if it's minus, and if it's plus, it's above the x-axis. So let's have a look at this one. 6 to the right and 1 down. So 6 to the right and 1 down, and we've got letter A. Okay. Now let's go for letter B. 12 to the right and 3 down. So 12 to the right and 3 down, we got letter B. 8 across and 5 up for C. 8 across, 5 up for C. And then finally D. 2 across, 7 into the air. So 2 across, 7 into the air. Now, it's looking like a parallelogram at the moment, because you can see the similar slopes for the two of them, okay? Now, what's going to ask me is, describe, the next question will be, describe 2 different ways of showing using a coordinate diagram, coordinate geometry techniques. So this means the techniques that are in your book, okay? So they're in your tables on page, for the most part, they're going to be on the coordinate geometry section of your tables, okay? So we're going to go to page coordinate geometry, page 18, okay, of your tables, okay? So page 18, there's going to be a lot of coordinate geometry formulas, okay? So just remember they're all on page 18, okay? So if you look up here, if I was to join these up, what we can say is that we can see that this sort of is a parallelogram, okay? So we can see very much it looks like a parallelogram there, okay? So the first method, okay? So what we could say is show that the opposite sides are parallel by showing the slopes of the opposite lines are equal, okay? So show that the opposite sides are parallel are parallel by showing the slopes of opposite lines are equal. Now, what this is basically, I go to my diagram, I show that DC and its opposite side AB have equal slopes, so they're parallel. Then I show that DA or AD has the same slope as BC. This proves it's a parallelogram. Okay, the next one I can do is second method. Show that the diagonals bisect. Show that the diagonals bisect each other by showing the midpoint of AC, the line AC equals the midpoint of DB. Now, I'm going to explain what this means now. So, you get your two diagonals. Okay, so what we have here is our two diagonals. I'll just do it in yep. So you have DB, and then you have AC. Now, what it means is that the diagonals bisect each other. It means that if I was to get this point here, call it M. M is the midpoint of AC, and it's also going to be the midpoint of DB. So this basically means that if this happens and the diagonals when they intersect, you create a point that cuts DB and AC in half. This means it's a parallelogram. Okay, so that's all you need to know about that. Okay, next one. You could also show that the opposite sides are equal in length using the length formula. So the last method here. Show that the opposite sides are equal in length using the length formula. Now remember the length formula, D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now what this basically means is I could just show that the let's just get rubber here. Okay, this is A and this one here is C. I can just show that DC is the same length as AB and DA is the same length as CB, and this will prove that it is indeed a parallelogram. Now some people might argue, does that not also prove that it's just a rectangular box or a square? It does, but you can also say that look, these are actually, a rectangular box is also a parallelogram because the sides are parallel to each other. Two sets of sides are parallel to each other, so it's also under the same criteria. Okay. Now, use one of the ways you've described to show that ABCD is a parallelogram. Okay, so what I'm going to use is I'm going to use the slope one. The first answer I gave would be the slope one. So show that the opposite sides of a parallelogram is showing the slopes of opposite sides are equal. Seems to be the quickest one. So the slope formula equals y2 minus y1 over x2 minus x1. We need to write down all 4 points again. So A is 6 minus 1. I'm going to show that the 2 points, the two lengths I'm looking to show, AD equals BC. So AD equals BC. The slope of AD equals BC. And the other I'm looking to show, AD equals BC. I'm looking to show that DC equals AB. B. Okay, B being 12 minus 3. C being 8, 5. And D being 2, 7. Okay, so we'll get started here. So I'll go for slope AB starting off. So slope AB, what I can say is x, y1, x1, x2, y2. Just put it right into the calculator, so we're going to get minus 3 minus 1 divided by 12 minus 6, straight into the calculator. With that you're going to get minus 1/3. You put that into the calculator. The next one we're going to get is the slope of DC. Slope DC, so we call this y2, x2, x1, y1. And we're going to get 7 minus 5 divided by 2 minus 8. And we're going to get we'll also get minus 1/3 for this one. And because the slopes are equal, this means that AB is parallel to DC. Okay, so AB is parallel to DC. Now, the next one after that, I need to get the slope of BC and the slope of AD. Okay, so BC and AD. So we'll try this one now. So I'm just going to rough this one out because I already used it. And we're going to go for the slope of BC equals, so slope, just rub out the previous x1s and y1s that we used up here. Now remember, x1 and y1 depends on the formula you're using, so you can just keep changing them. Okay, it's just you can use them once off and then change again. So slope BC, x2, y2, x1, y1. So what we're going to get is 5 minus 3, which is the same thing as 5 plus 3. Then we're going to have 8 minus 12 on the bottom. We're going to put that into the calculator and we're going to get minus 2 as our answer there. And then we're going to have a slope of AD. And this is going to be x1, y1, x2, y2. And then we're going to get 7 minus 1 divided by 2 minus 6. Put that into the calculator. So what I mean by putting in the calculator, just put it in exactly as it looks, okay? Nothing fancy about it, minus 2. And then we know that AD is parallel to BC, hence it's a parallelogram, okay? Hence ABDC is a parallelogram. ABCD is a parallelogram. Okay. Now, starting question 4. The diagram shows two circles C1 and C2 of equal radius. C1 has a center of 0, 0. So we know this here is going to be 0, 0. And it cuts the x-axis at 5, 0. So we know that's 5, 0. So what we can say right away is that that this here has a radius of 5. Okay, so we know right off the get-go that we're very much dealing with a radius of 5. Okay, so that's a radius of 5, which means it's also going to go 5 to the left. So this point here should also be minus 5, 0. Okay, find the equation of C1. Now to find the equation of C1, you need to look up your equation of a circle formula, and it's going to come in this form here. And what it's going to tell you in the notes is that R is the radius and HK is the center of the circle. Okay, so what we know about the center of this circle is that H is 0 and K is 0. So what we can get here is x minus 0 squared plus y minus 0 squared equals r squared, which is 5 squared. Therefore x squared plus y squared equals 25. Okay, next one. Show that the point minus 3, 4 is on C1. Now there's 3 rules, okay? When you have the equation of a circle, okay, you replace x with minus 3 because that's the x value, and y with 4. If it's on the circle, both sides will equal each other. If it's outside the circle, it will be greater than 25 when you put it in, and if it's inside the circle, it's going to be less than 25. So what we're predicting here is that it wants us to show. Show is the key in the language here. Show means it's got to be equal, so we should try this out. Minus 3 squared plus 4 squared equals 25. This is going to be 9 plus 16 equals 25. And then basically 25 equals 25. And then you can say, hence it's on the circle. Okay? Now, next question we're going to be asked now is the two circles touch at minus 3, 4. P is on the line joining the two circles. Find the equation of C2. So they touch at minus 3, 4. So let's go back to the diagram here. So this point here is minus 3, 4. Now what we can say is that if we were to join the two centers together and go through P until we hit the center, P is basically the midpoint between the two centers of the circle. Okay, so to figure out how we're going to go about doing this question, if I want to find the equation of C2, I want to find the equation of a circle. So first of all, I need to write down the formula for the circle. So x minus h squared plus y minus k squared equals r squared. Make a list of what I need. I need h, k and r. I know r already because it says they're equal. It says two equal circles of the same radius. I know the radius of the first circle is 5, therefore the radius of the second circle also has to be 5. I need to find out what HK is. That's the problem here. What is HK? Alright, so what I know is that there's a line that joins both of them to each other. Okay, and the center of the circle is 0, 0. Then halfway up, it's going to be minus 3, 4. And then it's going to go the same direction up and turn into HK, which is the center of the second circle. Okay, so basically this is what's going on here. I need it to be, and that's that one there. And then the second one, that's what's basically going on. Okay, so I need to figure out, so what we can say is that to go from 0, 0 to minus 3, 4 is you go across 3 and up 4. So 0, 0 turns into minus 3, 4, and it does that by going minus 3 to x and plus 4 to y. So it's going to go up again. So another minus 3 is minus 6. So h is minus 6. And k is another 4 into the air, which is 8. Because remember, it has to go up the same amount each time. You can see this by your eyesight. Left 3, up 4. Left 3, up 4. And that's going to get you to HK. Alright, so now we know the center of the circle. So also we have to say here, this is h and k, radius is 5. So next we have x minus bracket minus 6 squared plus y minus 8 squared equals 5 squared. And then you don't have to square these out for full marks. It's going to be x plus 6 squared plus y minus 8 squared equals 25. Okay. Now, the next thing it wants us to do, find the equation of the common tangent at P. Now, what is a tangent? A tangent is basically a line that cuts in one point only, and it says at P. So if it's at P, basically it has to just go straight through. Okay, so if it's at P, what we're going to have is it's just going to go straight through. So, excuse me, what? Back too far. So here we are, P, okay? So if you imagine I have a line, and I just want to make this line go through P, it just cuts it once, okay? So I have to find out what is the equation of this line, okay? Now, the way we're going to do this is there's a formula in your notes that actually does this straight out, okay? So the formula is something like this. If you go on to page 19, okay, you'll see something called you see equation of tangent, okay? So equation tangent is what it says at x1 y1. Now x1 y1 is the point it goes through, and we know that this is point P, so P is minus 3 4. So this is x1 y1, that's the point it goes through. Okay, and it will read this, it will say x minus h, x1 minus h, plus y minus k, y1 minus k, equals r squared. Now, you have a choice of two circles. You have a choice of two circles, as in which one would you like to use? Because it's tangents to both circles, so you can say that HK is 0 0, or you can say that HK is minus 6 8. So what we'll do is we'll do both of them just to prove that the answer doesn't matter. But you can use either one for this formula. So I'm going to use the HK is 0 0 because it's basically easier. So I'm going to have x minus 0, x1, and we know x1 is minus 3 minus 0, plus y minus k, so it's going to be y minus 0 times y1, which is 4, minus 0, equals r squared, and r is 5. Both radius of both circles is 5, so it doesn't matter, it's always going to be 5. So what we're going to have here is going to have x multiplied by 3, so it's going to be x bracket minus 3 plus y bracket 4. Bring over the 5 squared, which is 25. So what we're going to have here is minus 3x plus 4y minus 25 equals 0 is the equation of the line. But if you don't want it, you can also change that around by multiplying across by minus if it wants it, the x value is a positive. So both these lines are the same thing. You can multiply across by minus 1, change all the signs. Now, if we were to do this with 0 0, and instead we wanted to do it with 6 and 8, so minus 6 plus 8. So what we would have had here would have been this x minus 6 minus 3 minus minus 6 in brackets. We would have had plus y. I'm just using this formula again, and I'm going to use 6 8 this time. So y minus 8 y1 4 minus 8 equals 5 squared. So we would have had to tidy this up a little. So it would have been x minus 6 multiplied by minus 3. That's going to end up being plus 6. So it's going to be, just put it into the calculator here, and you would have got minus 3 plus 6 gives you plus 3. And then you would have had y minus 8 equals minus 4 here. Then bring over this, and it'll be minus 25 equals 0. And then what would be left with here would be multiply these out. So 3x minus 18 minus 4y plus 32 minus 25 equal to 0. Okay, and sorry guys, just a quick mistake on this one. It was x minus h, okay, and h is minus 6, so that would have made this one here minus 6, which is x plus 6, so that'd be plus 6 plus 18. Then when we add all them together, we would have got 3x minus 4y, that'd be plus 50 minus 25. So you actually get the same answer no matter which one you do, okay? But we can obviously see that because of the zeros in the first solution, that's the easier answer, okay? So now we're on question. I'm going to pause this for a minute. Okay, so next question. The diagram shows a circle inscribed in a square. The area of the square is 16 centimeters squared, right? So what you have to remember about squares is that the area of a square is length by width, and in a square the length and width are the same. So we're going to get is x by x and 16. So x multiplied by x is x squared. X squared equals 16. X equals 4. So this means the length of the square is 4. Now, if a circle just fits into this center, or just fits into this square, it means that its radius has to be half that of the length of the square, which is going to be 2. Find the radius length of the circle. The radius equals 2. Okay, and just show this workings here, right? Next part, part 2. Find the area of the shaded region in centimeters cubed, correct to one decimal place. So the shaded region is basically the square minus the circle. The area of the square minus the area of the circle. So basically we have a square here, and then you want to take away the area of the circle. Okay, so the circle would be something like that, maybe, just to fit in. So the area minus the slightly bigger circle. Okay, so what we know is that the area of the square is 4 by 4, 16 centimeters squared, and we know that the radius of the circle is of radius 2. Look up your notes on page. You're looking for your shapes, so this will be on page. The area of the circle will be on page 9, I think, 8 or 9 of your tables, page 8 of your tables, and you have area equals pi r squared. Use pi in your calculator, so area equals pi times 2 squared, and that will get you, pi times 2 squared will get you 12.566. So 16 minus 12.566, and what we get is, to one decimal place, it's going to be 3.433, so 3.4 centimeters squared. Okay, that's done. The next question. A solid wax candle is in the shape of a cylinder with a cone on top of it. Now remember, both of them, they have the same radius. That's the diameter. The radius is going to be 1.5 for both of them, because the diameter is 3, the radius is half that, so it's 1.5. Okay, the diameter of the base of the cylinder is 3 centimeters and the height of the cylinder is 8 centimeters. The volume of the wax in the candle is 21 pi centimeters cubed. Find the height of the candle. Okay. So the wax candle. The full candle is the cylinder and the cone on top. So what it's in effect asking me to do is it wants to find the distance from here all the way down to the base. So what we need to do is we need to call this H. Okay, so this extra part should be called H. Okay, find the height of the candle. So first of all, we're going to get it in terms of pi. See the way the answer is in terms of pi. We're going to get the area, or sorry, the volume of the cylinder part. Now, the volume of a cylinder, you're going to look this up on page, I think it's page 10. Page 10. Volume of cylinder is pi r squared h. So you're going to put pi in. You're going to get your 1.5 squared. And you're going to get your height of 8. And when you put all of that in, what you'll find is that it's 18 pi centimeters cubed. Okay, so it's 18 pi for the cylinder here. Okay, so 1.2.25 multiplied by 18 pi. This means that the volume of the cone, therefore, the volume of the cone part is going to be 21 pi, which is the volume of the full thing, minus 18 pi, which is equal to 3 pi. Now, next thing you need to do is you need to look up the volume of the cone part. Volume of a cone, once again in your notes on page 10, volume of a cone is 1/3 pi r squared h. And we know that that equals 3 pi. So what happens is 3 pi, so that's grand, and we know the radius is 1.5, so it's going to be 1/3 pi multiplied by 1.5 squared times h equals 3 pi. Put all of this part directly into the calculator. So what you're going to get is 1/3 multiplied by pi multiplied by 1.5 squared, and you're going to get 3/4 pi. So that's going to turn into 3/4 pi h equals 3 pi. Now you want to get the h on its own. So to get the h on its own, it's currently being multiplied by 3 pi over 4, 3/4 pi. Bringing that over the other side, it has to become divided. So 3 pi divided by 3/4 pi equals the height. So 3 divided by, once again, just put it directly into the calculator. Don't be playing around too much with it. H equals 4 centimeters. Okay. Now, that's not the height of the full candle. That's just the height of the cone bit. The cone bit is 4. Therefore, 8 plus 4, 8 centimeters plus your 4 centimeters gives you 12 centimeters. The height of the candle is 12 centimeters. Okay. 9 of these candles fit into a rectangular box. The base of the box is a square. Find the volume of the smallest rectangular box that the candles will fit into. Okay. So what we have here is we have a rectangular box like so, something like this. And what we know about the let's say the base of it is that it's a square. So if we were to draw this in here, okay, so what we know is that it's a square. So we can have these, that's a square bottom there, and it has to fit 9 of these candles into them. So square bottom. So 9 of these candles will fit into a rectangular box. So what I'm thinking is happening is if we were to draw out the square bottom, like so, and it has to be a square, what basically has to happen is 9 of these candles have to fit in. So it has to be 9 circles. 1, 2, 3, 4, 5, 6, Now that's 9 circles right there packed in together, okay? So if I was to make this container just that bit smaller, just so it barely fits in the 9 candles. So what I can say is that if the candles are in here, it has to be 12 centimeters tall. The full thing has to be 12 centimeters tall. Then what I know about each is from the previous question is each candle has a width of 3 centimeters each. So that's going to be 3 by 3 by 3. That's going to get me my 9 centimeters here. And then another 3, another 3, another 3. And that's going to get me my 9 here. Find the volume of the smallest rectangular box. So the volume of this rectangular box would therefore have to be, remember, volume of a box, this is not in your notes. It's length by width by height, or length by breadth by height. And it doesn't matter which one's which, so 9 by 9 by 12. And what we get here is 972 centimeters squared. Right, so it wasn't a bad question really. Alright. Now, next part. Write down a geometric result that can be used to construct a tangent to a circle at a point. Okay, so what we need to do, the tangent is perpendicular to the tangent's point of contact. The tangent is perpendicular to the line that joins the center of the circle to the point of contact. So what that basically means is if we were to have a circle here and I used to draw a tangent like so, it basically means if I have to center the circle here and I draw a line from the center going to center of circle, it's at 90 degrees, it's perpendicular to it. Okay? Now, on the diagram, construct a tangent at circle A. Okay, so construct a tangent. Okay, on the diagram shown, construct a tangent to a circle at A. So look, there's two ways of going about doing this, okay? I'll show you the first way. The first way is basically you get yourself the set square, okay, and you line it up at 90 degrees. So once you do this, you can make two lines. You can join it from the center of the circle here to A, and then you can make A, you can get a 90 degree angle from A onwards, like so. Then all we gotta do once that's done is you can then just finish off the line like so, and then you can make the finish off the straight line like so. Okay, so make it all one big go, and there you go, you get your tangent as seen here. Okay, now another way of going about doing it would be to you're allowed to join C to A, and what you can do is you can join C to A and go straight through the hit point and just continue on further like so. And the next thing you want to do is you want to get the perpendicular bisector of A to C. Okay, so you want to get the perpendicular bisector. So what you're going to do is you're going to measure off okay. So what we're going to do here is we're going to just first of all we're going to measure the distance from A upwards. So we're just going to have to make more space here. Okay. So what we're going to do is we're going to get A here, and we're going to measure the distance from A to C. So you're just going to position in your compass, okay, and you want to make sure that it's on point A, and then you want to get onto point C, like so. So and then you're going to rotate it in. Okay, it's probably too big here now, and so there you go there. Okay, then once you do that, you're going to make a mark like so, and then you can go all the way out the other side and make sure that you make a similar mark on the other side here. Okay, so now you have 2 points that are equal from each other. Okay, so next step after that is to get your compass back up again, and what you're going to do is you're going to measure from your compass. You're going to measure a distance that's bigger than a squared, so distance above distance far bigger than a squared here. Okay, and what you're going to do next is you're going to make 2 marks down here, so 1 mark down here like so, and then you're going to make a mark above the line like so. Okay, then you're going to come over the other side, this one here, and then you're going to repeat the same procedure down the other side. So you get a mark here, and then you rotate around, and then you're going to get another mark here, and as you can see, it's just after cutting in half there. And then what you can get here is by joining these 2 points here, what we can construct ourselves is a nice tangent, and we see the tangent there. Okay, now next one after that, it wants me to construct the circumcenter and circumcircle of the triangle below using only a straight edge and a compass. Show all construction marks clearly. Now, unlike the first question, it didn't mention anything about construction marks in the last question. So, but this one here wants me to show all the construction marks clearly. Okay. So, what we're going to do regards to circumcircle is we have this here. So circumcircle means basically we're going to try and draw a circle around this full triangle. So we're going to hopefully end up with something that basically contains all the points, contains all the angles of the circle, but it's just slightly bigger. So we try to get this in, okay? Okay, so what we're going to do is we're going to try and figure this out. So in order to do this, we're just going to get the compass. So I think the compass is up the page at this stage, so we'll just bring it down here and we'll get going on how to do this. Okay, now for the circumcircle, you got to do bisectors. Okay, so you got to bisect the angles like we did in the last question. So what we're going to do is we're going to pick a distance that's above halfway on the length. So we're going to make this as big as we can, and we want it to go above halfway. So what we're going to do is above and below the line, we're going to make a mark. Okay, so here's the first mark here. Then we're going to swing it around the other side and get the second mark here. Now that's done, what we're going to do next is I'm going to bring this up here, once again on the same mark, and then we have our second mark here. And don't forget that you have to go all the way over to your side. So we're just going to rotate this around until we're close to your side, and we're going to draw this here. And as you can see, it cuts nicely. So there's our two points, and this is what's called the perpendicular bisector. Okay, so when we join these 2 lines together, what we're going to do is we're going to cut this one in half. Okay, so this I'll just after cutting this length in half. Now what I have to do is I have to do this again. So in order to do this again, what I'm going to do is just going to use the same length I used already on the compass. Going to bring it over to the other point here. And once again, we're going to do it above and below the line. So, might use a different color this time, just to denote that we're using different colored pens. Okay, so the first part here, it's red on top. Then we're going to rotate around to the bottom. Okay, there's the second one. And then once we've done that, we need to go to the other side. Go to the same point here. Okay. Now, I need to draw this. Now, what happened here was these guys haven't intersected yet, so it means I obviously didn't make my my line marks long enough. Okay, so we gotta go back there and redo the first one because they haven't cut each other yet. Okay, so we go back to the start here, turn it around, then finish off. There's the first one. And the second one will be down here. So now they cut nicely, okay? So just remember to make your marks long enough. Then we can draw a line from here to here. We need to undo that. Needs to be accurate, guys, so make sure it's very accurate when you're drawing this. It goes all the way through. Now remember to continue through your line when you're doing this. So, and continue through your mark. Now you can see where they both cut. The two black lines are now cutting in a certain position. This position is basically the center of your circle. Okay, so this red mark here is this center of your circle. Okay. So what should happen next is we should be able to bring the compass to the center of this circle. Okay, and I need to pick one of the sides. So I'm hoping to pick this side here. And what should happen is, when I pick this side here, it should basically, I want to make sure that it's just right on the tip of the mark here. Now, I am in the center of this circle at all, so I need to make sure I'm right on the center. Now that that's done, I'm going to try and draw the circle all the way around, like so. Now you can see I'm slightly inaccurate with my drawings. There's a slight inaccuracy, but for the most part it's a very good drawing. You can see that the centers should touch in one position only. So here's 1, 2, and 3. So it's just slightly off, but for the most part it's a very good construction. Okay, now that concludes the end of section 1.